I can solve one and two-step compare problems using data represented in scaled bar graphs. In this lesson, you're going to connect what you know about reading bar graphs to solve one-step and two-step problems. You're going to learn to make sense of problems that involve comparing. You're going to use bar graphs to help you visualize and make sense of relationships between amounts in comparing situations. So let's review what we've learned in the previous lessons. Suppose I have a bar graph about students' favorite sports. It shows that the greatest number of students like basketball. Looking at these two bars, which bar would you think would be the data for basketball? Remember, it should show that the greatest number of students like basketball. Well, looking at these two bars, this would be the bar that would represent the bar for basketball, since the bar for basketball would be the longest bar. What do you think a good title for this graph would be? Well, since it is a bar graph about the students' favorite sports, we can use favorite sport for the title. Let's look at this following problem. Derek's class voted on a topic for the school bulletin board. This bar graph shows the results. How many more votes did computers receive than space? So let's figure out exactly what is it that we have to answer. So there's that question mark. So this is the question part of the word problem. Let's read it again. How many more votes did computers receive than space? So we're looking at the data for computers and for space. So since for this question we're concerned with just computers and space, we're going to direct our attention to the data for just computers and for space. So let's look at that. So looking at the bar for computers, we can see that 10 people voted for computers. For space, we can see that only 3 students voted for space. And how can we tell that it's 3? Well, if we look at the end of the bar, it ends right there. And that is in between the number 2 and 4. And what number is in between 2 and 4? Well, it's 3. 2, 3, 4. So, our question again is, how many more votes did computers receive than space? Well, there's a couple of ways that we can figure this out. The first way is to use a model, which would be this bar graph. We can count back along the scale to find the difference between the bars to figure that out. You can see that computers is more than space. Well, how many more? Well, first thing, let's look at the scale. Remember, the scale is the numbers. So we have 0, 2, 4, 6, 8, 10, 12. That's not counting by ones, that would be counting by twos. So the space between each of the numbers is 2. So counting back from computers to space, we would end right here. So this would be 2, 2, 2, and just 1. And now we can count back. So that would be 2, 4, 6, and one more is 7. So the difference would be 7, or in this case, 7 votes. Another way to find the answer to the question, how many more votes did computers receive than space, would be to write a number sentence. So let's see how that would go. So since the question is asking how many more votes did computers receive than space, we know that we are comparing something. So definitely it is not combining, so it won't be addition. Remember, when we are comparing, that has to be subtraction. So let's think. How many votes were there for computers? Well, going back in the graph, you see that there were 10 votes. And how many votes were there for space? Going back to the graph, you see that there were only 3 votes. So we can simply write 10 votes minus the 3 votes, and that would equal 7. So again, computers received 7 more votes than space. Now let's look at another example. Brooks' school collected cans of food. The bar graph at the right shows the number of cans. How many fewer cans were collected on Tuesday than on Thursday and Friday combined? So here is the question part of our word problem. Let's read that again. How many fewer cans were collected on Tuesday than on Thursday and Friday combined? So in this word problem, we need to figure out, or we need to compare the cans collected on Tuesday and on Thursday and Friday combined. Now there's that word combined. We know already when we are combining something, it is addition. We need to put something together. So what are we putting together? Well, it says Thursday and Friday combined. So first, let's look at our data in this bar graph. Let's start with figuring out how many cans were collected on each day. So here is a labeled day. So on Tuesday, how many cans were collected? Well, the bar ends right here in between 12 and 16. That's a little weird. Let's look at the scale. Remember, when we're looking at the scale, we're looking at the numbers. So the label underneath the numbers, or the scale, reads number of cans. So we're talking about the cans here. Now looking at the scale, it goes from 0 to 4 to 8, 12, 16, 20, 24, and then 28. Well, that's definitely not counting by ones. Otherwise, I would say 0, 1, 2, 3. It's not counting by twos because that would be 0, 2, 4, 6, and that's not what it says. Well, it's not threes because it goes from 0 to 4. Could it be possibly counting by fours? Well, yes, it is. 0, 4, 8, 12, 16, until 28. That is counting by fours. So each space represents 4. So, going back to Tuesday, we see that it is in between 12 and 16. So if we draw a line there, just to help us, what numbers would be in between 12 and 16? So what numbers would be in between 12 and 16? So let's take a moment to look at that. So here we have a number line. So let's see. So we would have 12, and we want to know what's between that number and the number 16. So let's look there. So you see, between 12 and 16, we would have the numbers 13, 14, 15. So which number would be right in the middle? Well, that would be the number 14. And you can clearly see here that there's 2 lines before 14 and 2 lines after 14. So 14 would be right in the middle. So on Tuesday, how many cans were collected? Well, the answer is right there. On Tuesday, 14 cans were collected. Now, on Wednesday, how many cans were collected on Wednesday? So the bar ends right on a line, and that is 16. Thursday, 24 cans were collected. And on Friday, that bar ends in between 24 and 28. So what number would be right in between 24 and 28? So let's again look at a number line to see which number would be in between 24 and 28. So here's a number line. So let's focus on just between 24 and 28. So let's look carefully and see. There's a number 24 and there's 28. Which number would be right in the middle? Well, that would be the number 26. And again, just to make sure, you can see that there's 2 numbers before 26 and 2 numbers after 26. So going back to our question, how many cans were collected on Friday? That would be 26 cans. So, going back to our question in the word problem. How many fewer cans were collected on Tuesday than on Thursday and Friday combined? So the first step that we need to do is, well, we need to combine the totals of Thursday and Friday. Remember, when we're combining, that means we're putting it together, and in this case, it would be addition. So on Thursday, we know that 24 cans were collected. And on Friday, 26 cans were collected. So let's go ahead and combine that first. As always, we start with the ones column. 4 plus 6 equals 10. We group that 1, 10. Then we have 2 plus 2 equals 4, and 1 more is 5, 50. So the total for Thursday and Friday were 50 cans. Now we know that Thursday and Friday had 50 cans. Now we could go ahead and figure out how many fewer cans were collected on Tuesday. So how many cans were collected on Tuesday? 14. Remember, when we compare, we subtract. So we would simply do 50 cans from Thursday and Friday combined minus what was collected on Tuesday, which was 14. As always, we start with the ones column. 0 minus 4, well, we know we would have to regroup. We can't take away 4 from 0. So going over to the ones column, tens column, we take 1 10, which would leave us with 4 tens. Adding that 1 10 to 0 ones gives us 10. Now, 10 minus 4 gives us 6. And then 4 minus 1 is 3. So, 36 fewer cans were collected on Tuesday, then on Thursday and Friday combined. So, you notice that we needed more than one step to solve this problem. Why was that? Well, first we needed to find the number of cans that were collected on Thursday and Friday combined before we were able to compare or subtract to find how many fewer cans were collected on Tuesday. So this was a two-step compare problem. In this lesson, you learned how to solve one- and two-step compare problems using data represented in scaled bar graphs.